This is SpaceTime Series 27, Episode 36, for broadcast on the 20th of March 2024. Coming up on SpaceTime, discovery of a giant volcano on Mars, a new radar mission for the European Space Agency, and could a robotic chemist create oxygen from resources already on Mars? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered what appears to be a giant ancient volcano and glacial ice sheet buried in the eastern part of the Martian Tharsus volcanic province near the red planet's equator. Amazingly, this structure has remained undetected, literally hiding in plain sight, despite being repeatedly imaged by orbiting spacecraft going all the way back to Mariner 9 in 1971. Scientists say it was never identified as a volcano simply because it was so deeply eroded beyond any easy recognition. Still, for decades, this giant volcano has been one of Mars's most iconic regions. It's right at the boundary of the highly fractured maze-like Noctus Labyrinthus, the Labyrinth of the Night, and the monumental Valles Marineris, or Valleys of the Mariner Canyons, which form a massive split in the red planet's crust. Provisionally named Noctus Volcano, pending an official title, the structure is centered some 7 degrees 35 minutes south, 93 degrees 55 minutes west. It reaches over 9,022 meters, that's 29,600 feet in height, and spans some 450 kilometers or 280 miles across. The volcano's gigantic size and its complex modification history indicate that it must have been active for a very long time. In its southeastern part lies a thin recent volcanic deposit beneath which glacial ice appears to be still present. This combined giant volcano and possible glacier discovery is significant as it points to an existing new location to study Mars's geologic evolution through time, to search for possible signs of Martian life, if it ever existed on the red planet, and to explore with both robots and ultimately humans in the future. The study's lead author Pascal Lee from the SETI Institute and NASA's Ames Research Center says he and his team were examining the geology of the area where they just found the remains of a glacier when they suddenly realized they were actually inside a huge and deeply eroded volcano. Now, there were several clues which, when finally put together, gave away the volcanic nature of the jumble of layered mesas and canyons in the eastern part of Noctus Labyrinthus. Now, firstly, there was the central summit area, which was marked by several elevated mesas forming a sort of arc, reaching a regional high and then sloping downwards away from the summit area. Then there were the more gentle outer slopes. They were extending out some 225 kilometers away from the central summit in all directions. There was also a caldera remnant, the remains of a collapsed volcanic crater once host to a lava lake. That was right near the center of the structure. Finally, there were lava flows, pyroclastic deposits made from volcanic particulate materials such as ash, cinders, pumice and tephra, and hydrated mineral deposits were detected at several locations within the structure's perimeter. In fact, this whole area of Mars is already known to have a wide variety of hydrated minerals spanning a long stretch of Martian history, and a volcanic setting for these minerals had long been suspected. So it may not have been too surprising for scientists to finally find the so-called smoking gun volcano there. In addition to the volcano, the scientists also discovered a large 5,000 square kilometre area of volcanic deposits within the volcano's perimeter, which feature a large number of rounded, elongated, blister-like mounds. This so-called blistered terrain is being interpreted as a field of rootless cones, mounds produced by explosive steam venting or steam swelling, when a thin blanket of hot volcanic minerals comes to rest on top of a water or ice-rich surface. The find follows the earlier discovery of the spectacular remnant of a glacier, or relic glacier, through a sizable erosional opening in the same volcanic blanket in the form of a light-toned deposit of sulfate salts with the morphologic traits of a glacier. The sulfate deposits are made mainly of jarosite, that's a hydrous sulfate, and they've been interpreted to have formed when the blanket of volcanic pyroclastic materials came to rest on the glacier and then reacted chemically with the ice. The breached rootless cones identified in this study show similar properties to polyhydrated sulfides, further suggesting that the blistered volcanic blanket may be hiding a vast sheet of glacial ice beneath it. The Noctus Volcano presents a long and complex history of modification, possibly from a combination of fracturing, thermal erosion, and glacial erosion. The study's authors are interpreting this volcano to be a vast shield made of layered accumulations of pyroclastic materials, lavas, and ices, the latter resulting from repeated buildups of snow and glaciers on its flanks throughout time. As fractures and faults eventually developed, in particular in connection with the uplift of the broader Tharsus region where the volcano sits, lavas began to rise through different parts of the volcano, leading to thermal erosion and the removal of vast amounts of buried ice, as well as the catastrophic collapse of entire sections of the volcano. Subsequent glaciations continued their erosion, giving many canyons within the structure their current distinctive shapes. But much about this newly discovered giant volcano still remains a mystery. Although it's clear that it would have been active for a long period of time and probably began its build-up early in Martian history, it's unknown exactly how early that was. Similarly, although it shows clear evidence of having also experienced eruptions even in modern Martian times, it's unknown if it's still volcanically active and might erupt again. And if it has been active for a long period of time, there's a tantalizing question. Could the combination of sustained warmth and water from ice have allowed the site to become habitable? Could life have formed there? This is SpaceTime. Still to come, a new radar mission for Europe and a busy time with lots of comings and goings aboard the International Space Station. All that and more still to come on SpaceTime. The European Space Agency are planning a new Earth observation mission to monitor how the planet is changing due to global warming. The Copernicus Radar Observation System for Europe in L-band, or Roselle spacecraft, will provide continuous day and night all-weather monitoring of the Earth's oceans, land and ice, together with other frequent observations of the planet's surface at high spatial resolution. Built by Thales Alenia Space, Roselle is one of 6 Copernicus Sentinel expansion missions that ESA is developing on behalf of the European Union. These missions are designed to expand the current capabilities of the Copernicus Space Component, which is already the world's largest supplier of Earth observation data. The 2,060-kilogram Roselle spacecraft will carry an active phased array synthetic aperture radar. The radar antenna will be the largest deployable planar antenna ever built, measuring an impressive 40 square meters in size. Roselle will deliver many benefits, including essential information on forests and land cover, and that'll lead to improved monitoring of terrestrial carbon cycles and carbon accounting. Now, since the longer L-band signal being projected by Roselle will be able to penetrate through many natural materials such as vegetation, dry snow and ice, the mission will provide additional information that simply can't be gathered by the Copernicus Sentinel-1 C-band radar mission. It'll be used to support forest management, to monitor subsidence and soil moisture, and to pick out different crop types for precision farming and food security. In addition, the mission will contribute to the monitoring of polar ice sheets and ice caps, sea ice extent in the polar regions, and seasonal snow. The mission will also greatly extend science's ability to monitor minute surface displacements, thereby helping to at least detect geohazards. It'll map surface soil moisture conditions over land, helping improve hydrology and weather forecasts, and support the operational monitoring of sea and land ice across the Arctic. This report from ESA TV.
Roselle is the largest planar ROSAL antenna ever built, with an area of 40 square meters.
It's the first time we use a longer wavelength, and because of this longer wavelength, we collect new information from space that is not yet accessible or that is not yet collected by other satellites.
The first European mission to fly a software-defined radar.
Not many people know that 15 countries are involved in the building of Roselle. This is truly a European project.
We have X-band missions, we have C-band missions like Sentinel-1, and now we have L-band missions. Roselle, as the name implies, stands for Radar Observing System for Europe at L-band. The term L-band here refers to the wavelength that is being used. L-band is a longer wavelength, much longer than Sentinel-1. Both of them provide a different information that can be combined and gives you a better view of the Earth together. They also complement each other by flying in the same orbit and collecting information at regular intervals over the same area. So it can be used as a single system, just like we use our eyes, also as a single system, as a single way of looking at the world around us. My name is Malcolm Davidson, and I work as a Roselle mission scientist in ESA. What kind of information does Roselle provide? Well, it provides information on the sea ice, the different sea ice types that are there. It tells us whether ships can navigate safely, and being able to detect these ships even when there are clouds or there is darkness or indeed some storms. This information about ships is useful for security applications. It's also useful for safety applications and for ecosystem applications. One of the important ecosystem applications is, for instance, oil spills, where monitoring the oil spill, the extent of the oil spill, and the severity of the oil spill is extremely important. Roselle also has a very good role to play in climate change or the monitoring the effects of climate change. The fact that the ice sheets are melting, how quickly they are melting, how much water is being released as they melt, are some of the questions that Roselle helps answer. Another important area that Roselle supports is agriculture. And agriculture is linked to food security. By providing high-resolution soil moisture information, Roselle contributes to better crop management practices. Another important role that Roselle plays is in terms of forest carbon stocks. When I say forest carbon stocks, I'm talking about monitoring the forests across our globe and making an inventory of how much carbon lies within these forests. Roselle contributes to the safety of European citizens by monitoring geohazards. Geohazards are typically what we think of when we think of disasters, natural disasters, such as landslides, such as subsidence when buildings and other structures are sinking into the ground. And earthquakes and volcanoes, of course, are well known. Roselle is able to penetrate through the vegetation with its long wavelength and sense the movements as they take place and even a little before they take place. And this type of information is inaccessible to the current generation of Copernicus satellites and is a unique characteristic of Roselle.
In order to meet the challenging quality requirements, state-of-the-art technology is required all across the instrument. My name is Nico, I'm Nico Gebert, and my job is the Roselle payload manager. The mission objectives of Roselle require to image a large area, we call it a swath, with fine level of detail, so a high resolution. More specifically, the satellite can image a strip on ground of 260 kilometer width, and one will be able to distinguish structures down to a size of 5 to 10 meters. So Roselle is the first radar mission in Europe which will provide so much information. In addition, we need to transmit a lot of power to see also weak, so small targets on the ground. It's a bit like using a strong torch to be able to see also in the darkest corners.
Roselle provides groundbreaking high-resolution information on ice condition in the Arctic, even in condition of complete winter darkness, supporting safe navigation.
Roselle pierces the darkness with the help of its own illumination. It illuminates the surface below and collects information in the Arctic, even in the height of winter.
It is a combination of different techniques. For For example, when receiving the echo from the ground, the antenna dynamically sweeps the beam across the ground to follow the position of the echo. At the same time, 5 different data streams are transferred to ground. This is what we call digital beamforming. We have split the large antenna into many small antennas, which we can then individually control, both when transmitting and as well when receiving the echo. It's a bit like a car, which at the same time should be small, provide a lot of space, and go fast, but with little fuel consumption. This means we needed to design an instrument which is quite special. We are developing power modules of unprecedented peak power in Europe. Such peak power requires a sophisticated design, which comes with a lot of challenges. Overall, we radiate 9 kilowatts of power, which is actually enough to heat my complete house in the winter.
My name is Gianluigi Di Cosimo. I am the Roselle project manager. If I have to make an example of a key technology which has been specifically developed for Roselle, I should mention the transmit-receiver modules, which are the heart of the antenna front-end electronics. For those elements, we had to run some pre-development activities, testing that the technology was mature enough to be embarked on the Roselle missions.
We needed to move away from classic design of radar instruments, which consists of one large antenna. In simple words, we're having 60 small antennas, which we can flexibly reconfigure by changing the software. In addition, we're transferring several data streams to the ground, which gives a lot of flexibility to process the data in many different ways. In this respect, Roselle is truly a software-defined radar. So it was tested over the large range of temperature variation that we see in orbit to check how much it deforms. And although the dimensions are huge, it's 2.2 meters by 30 centimeters, this sample is quite light and it doesn't weigh more than a couple of kilograms. Well, it has to be light because if the antenna gets too heavy, then the launcher could not carry it up to the orbit. So actually it's a feature of our instrument to keep the antenna very lightweight, so it's really a novel technology. Imaging such a wide area of 260 kilometers with a fine level of detail comes with a massive amount of data. On average, Roselle will produce 6.5 terabytes of information every 100 minutes. This means almost 100 terabytes of data every day. For comparison, this would correspond to almost 4,000 hours of Netflix videos in high definition every day.
Each Roselle spacecraft is designed to remain operational 7.5 years.
One important characteristic of Roselle is that it is an operational mission. Operational in the sense that it acquires data all the time. It makes the data available quickly so that it can be used for the different applications. And thirdly, it follows an open data policy which supports many different new applications and enables scientists to investigate how best to use the data in new types of applications that don't yet exist but will exist in the future.
According to the current planning, Roselle will be ready for launch in 2028.
And it is based on the most powerful radar electronics ever, reconfigurable from ground.
This is SpaceTime. Still to come, busy times aboard the International Space Station with lots of coming and going. And could a robot chemist create oxygen from resources already available on Mars? All that and more still to come on SpaceTime. Well, it's been a busy time aboard the International Space Station, with several crews arriving and departing over the past few weeks. Last month, SpaceX launched the Dragon capsule bound for the International Space Station, carrying a 4-person team from Axiom Space. This was Axiom's third private space mission to the orbiting outpost and was designed to undertake a series of experimental projects for the company. Axiom's planning to undertake a 4th mission to the ISS later this year, possibly in October. The company is also developing its own modules for the International Space Station. They'll be built over the next few years, with the first expected to be launched and docked to the ISS in 2026. Ultimately, when the International Space Station is finally deorbited, Axiom plans to use their modules as the basis for their own future orbiting space station. The Axiom crew remained on station for almost 3 weeks before returning to Earth and splashing down in the North Atlantic Ocean off the coast of Florida. No sooner were they gone when another 4-person crew flew up to the orbiting outpost, also aboard a Dragon capsule launched on a Falcon 9 rocket from the Kennedy Space Center. Their Dragon Endeavour capsule docked with the space station's Harmony module's space-facing port. It was a case of second-time lucky for this mission. The first attempt a few days earlier had to be scrubbed due to high winds. The launch also marked the 5th flight for the same Endeavour capsule. The NASA SpaceX Crew 8, as they're called, will spend the next 6 months on station, undertaking experiments on stem cells to create organoids. These are artificially grown masses of cells resembling organs, which will be used to study degenerative diseases. They'll be taking advantage of the microgravity environment of space to enable three-dimensional cell growth in these organoids, which is not always possible on Earth. The new crew are replacing NASA's SpaceX Crew 7 team, who left a few days later aboard their own Dragon spacecraft, signaling the end of Expeditions 69 and 70. Their 6-month tour aboard the ISS involved taking part in more than 250 experiments and spacewalks, including research into microgravity's impact on immune cells and liver regeneration, which could potentially offer new insights into aging and disease. Other experiments included protein crystal growth in microgravity, studies into artificial retina manufacturing in space, projects to reduce the material mass being transported into space, research into antimicrobial coatings for use in space travel, the development of better therapeutics for use in drugs, optical fiber production in microgravity, and a study of heart muscle cell development in space. The NASA Dragon Crew 7 capsule splashed down safely in the Gulf of Mexico, just near the Florida Panhandle. Meanwhile, yet another leak, it's either the 6th or 7th, I lose count, has developed aboard the Russian portion of the space station. NASA says it's keeping a close eye on this latest leak, with hatches being kept closed to isolate the leak from the rest of the space station, while the Russians try to find out exactly where it is. This is SpaceTime. Still to come, could a robotic chemist create oxygen out of the resources already available on Mars? And later in the science report, a new study warns that high temperatures above 33 degrees can immediately increase your risk of having an ischemic stroke. All that and more still to come on SpaceTime. Scientists have developed an AI robot chemist that can make oxygen from Martian meteorites. The research, reported in the journal Nature, claims similar technology could one day make human missions to Mars easier and more cost-effective. The robot was given 5 categories of meteorites known to exist on Mars in order to analyze them, and it was able to identify chemicals in the meteorites that could react together to produce oxygen. It achieved this by painstakingly testing the performance of different strategies of oxygen production until it found the best one. Now, that same process would have taken humans more than 2,000 years. The researchers say technology like this could one day allow future Mars missions to produce oxygen for rockets and life support systems using materials already available on the Red Planet. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that high temperatures over 33 degrees Celsius can immediately increase your risk of having an ischemic stroke. The findings, reported in the Journal of the American Medical Association, show that compared to temperatures of around 12 degrees, at 33 degrees there was an increased risk of stroke in the first hour, and the increase lasted for 10 hours after exposure to that heat. The authors say the new findings may help medical practitioners devise new public health strategies to reduce the risk associated with high ambient temperatures under the current effects of global warming. Scientists have found increasing evidence that whales that get stuck in discarded fishing gear wind up having serious lifelong injuries. That's assuming they survive in the first place. The findings, reported in the Journal of Proceedings of the Royal Society B Biological Sciences, are based on studies of North Atlantic right whales. The authors found that even if the mammals survive the encounter, they wind up with all kinds of medical issues. The researchers used information from 199 female whales sighted between 1977 and 2018, combined with known information about entanglements classed as minor, moderate or severe. They found that, as you'd expect, severe entanglements had the biggest impact on survival. However, even whales who experienced only minor entanglements still showed issues, such as these whales having the lowest probability of becoming breeders. Scientists found that almost all females, some 89%, have experienced at least one entanglement event during their lifetimes, and some 2/3 have experienced 2 or more events. The authors say that as one of the most endangered great whales, management actions are needed to address all kinds of entanglements in fishing gear, even minor ones, if the North Atlantic right whale population is meant to recover. A new study shows that spent brewer's yeast, that's the basis of Australia's much-loved breakfast spread Vegemite, can also be used multiple times to pull metals out of water. A report in the journal Frontiers of Bioengineering and Biotechnology claims this extract was able to pull metals such as aluminum, zinc and copper out of a solution. And when tested on a metal-loaded waste stream, they found it was able to pull 50% of copper and 90% of zinc that was present in the water. And the authors say the yeast can be reused and recycled multiple times, making the process even more eco-friendly. Well, it seems both TikTok and Metta are in the spotlight this week for all the wrong reasons. Metta, the parent company of Facebook and Instagram, are trying to back out of paying for news content on their platforms. Meanwhile, technology editor Alex Zaharov-Reut from TechAdvice.life says American politicians want to force Chinese-owned ByteDance to divest itself of TikTok. It's because of the influence the social media platform has, its use to spy on its users, and the propaganda it pushes as news.
The US wants ByteDance, the company that owns TikTok, to divest it and sell it to a non-Chinese-based interest, because what they're saying is that it's a tool used by the Chinese government to spy on people, to collect all this information on all these different users, and also to manipulate them with really quite inane content, people doing crazy challenges or doing silly dance moves, whereas the version of TikTok that is allowed in China, which is owned by the same company, but it has a very different sort of mindset in that...
It's more educational there, isn't it?
It's much more educational,
limits the amount of time you can be on it if you're a kid, whereas the version we see in the West, which the United States gets, and us here too, I guess, is one which is pushing very strong political viewpoints. These are to people who, firstly, are usually young and consequently are easily influenced anyway, and secondly, it's often the only news source they have.
Well, that is one of the concerns. Yeah, people are going towards social media as their news source. And look, just because the mainstream media says something on the news doesn't necessarily mean that it's true, but definitely your social media platforms, which it's right there in your face. I mean, you are very intimate with your phone. People tend to take that a lot more seriously, and they tend to take what an influencer says. TikTok has been extremely successful in being very addictive, and the concern about its algorithm pushing various viewpoints is real. Now, in the States, the House has voted to ban TikTok, but it still needs approval by the Senate. And then, of course, the president himself could also veto that. And this would all sort of go
TikTok,
away.
Isn't he? So, we don't know what's going to happen there.
Well, we don't, yeah.
Now, on a related topic, Metta have decided they're going to not pay for news content on their Australian platform.
Well, this is something that Facebook has announced, or Metta has announced that it's doing not just in Australia, but in the US and a number of other countries, because Facebook was paying out tens of millions of dollars to various news organisations around the world, in Australia and around the world. And a number of those organisations actually use that money to employ local reporters in country areas, for example. And those publications said, well, if we're not getting the money from Facebook, we're going to have to scale back. The problem with Facebook has always been one of trust. Mark Zuckerberg has been on a 20-year apology tour for misusing the data of its users. Mark was in Congress only earlier this year, being forced to apologize to parents whose children were on Instagram and who were sexually groomed. And in fact, Ted Cruz, the US Senator, was questioning Mark Zuckerberg, saying, when people were searching for pedophile-style material, instead of outright blocking people from that, it issued a warning. And then one of the buttons said words to the effect of, have a look at it anyway. And Ted Cruz was completely flabbergasted at how this could be the case when any other sort of social media engine or search engine would outright block you from viewing that content. So there's a question of trust with Mark Zuckerberg and Facebook.
And just before we go, Microsoft are about to make some big announcements with new releases.
Yeah, March 21 in the US, March 22 in Australia, we'll see the Surface Pro 10, which is their cross between a tablet, an iPad-style device, and a laptop, and also the Surface Laptop 6, which is a laptop. And there's meant to be OLED screens with HDR capabilities. There's meant to be the Intel Core Ultra processor with the built-in NPU, neural processing engine, unit for AI stuff, and also the Snapdragon X Elite, which also has a built-in AI component. And there's meant to be a new thing called AI Explorer, where it will look at everything on your computer, and you can say, hey, show me that thing with dinosaurs, and it will look up the last time you mentioned dinosaurs, search for it, brought up images about it. There are concerns that is going to eliminate your privacy, but it certainly would help allow you to sort of search through your life with ease, and with AI's help in doing that. There'll be an AI key, there'll be faster ports and sleeker designs. So we'll get all the details in about a week's time after it's all launched. Pretty soon, every PC will be an AI PC that can do various AI tasks right on the device itself and not have to send all that information and requests to the cloud.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.